Public service reserve the IP address. Is that something manual or dynamic? It won't be a static IP. You would get one of the IP which is available in the subnet directly. You would get one of the IP address which is available directly. Yes, go for it.
Yes. So okay. So first thing, service endpoint to an Azure application or platform. So you create a service endpoint in a subnet, right? And
Yeah.
you link that service endpoint to a past Azure
Yes.
application or system. Okay.
Yeah.
Storage or SQL.
Yeah.
Of course, you have all the underneath, like routing and firewall in place to allow the traffic to go from that subnet to the public, endpoint, right?
Exactly.
Okay,
And
so the
it's
traffic go from, the subnet to, firewall, whatever, go to the internet and go to the public endpoint of that service, right?
yes, exactly.
Okay, so with private endpoint, you create a private endpoint in a subnet, and then you link it, like somehow to the public's, application or service using a private IP address. I I'm not sure how to set it up, but
I'll just show you.
I believe the traffic going from subnet to subnet, and it doesn't go to the internet, right?
It nothing exits the internet. It's going to be subnet. What it basically does in the backend, when I create a private link, it creates this p link or p nick basically. It creates a p nick for this Azure bus, which gets injected here, and this gets an IP from one of the IP from the subnet. So this gets 1.2, and then your communication goes. So in the back end, if you look at this virtual machine and if you look at the routing of this virtual machine, you can see this link up and the traffic going over this pnic. So the next hop for this Azure PaaS service would be this pnic.
Okay, beautiful. It's clear now. Yeah.
Perfect.
So basically, when you set up that private endpoint in that subnet, it will create a PNIC and
Yes.
inject it into that subnet, or the routing table of that subnet or the route table of that subnet. So whenever traffic designated to that public service, it will using that PNIC IP address at the next destination, right? Next host.
Yes. Yes.
Clear
Well
enough.
done.
Okay.
I'm so happy. Exactly
Yep.
right. Okay. Moses, I would imagine pass to pass communication, that is app service to storage account traffic, would be going through. It really depends how you configure it, honestly. Again, everything comes back to routing. Whenever we create a service endpoint or private endpoint, it's just at the backend, the system defined route, you have this route in the backend. That's pretty much it. In the front end, it looks like, hey, this traffic, oh, something fancy is going on. But in the back end, if you look, like the routing basically changes a little bit. That's it. So everything is the magic of routing.
So speaking of the routing, what if the IP range changes on the endpoint? I mean, the end destination. So does it get reflected
Yes.
in the endpoint routing?
Yes, automatically. This creates a system-defined route in the backend. System-defined route, that means I can't create it, I can't delete it. Just at the backend, it gets created automatically. So everything is dynamic. Okay, what is the bandwidth of PNEC? Do we have speed selection? Probably not. I'll have to check on that. Good questions, John. I'll probably get back to you with these questions. Now, private endpoint is a little bit difficult to set up, but I'll just quickly show you how to do it. So private. So if you come to private link, you can start creating your private endpoint, and then you can start linking it to the virtual network that you want. So this is a private endpoint. You can start creating this private endpoint and then link it to the service that you want it to. So this is how it works. So I have created a private endpoint already. I hope it's still there. So this is a private link. So as you can see, this is a DB resource from this subnet has a private IP. Where is this private IP coming from? This PNEC IP, it is coming from this subnet. This subnet. So this is how you can create it. Once you create it, it's very simple to set up, but it just takes a lot of time to come up. Okay, I'll just quickly look at Bhaskar. What's up with him? I think he's pinging me at the back. I'm not. Okay. Bhaskar, if you're still there, it's fine. It's something that I've done. But
I'm here, but I cannot
it's okay. I'll just
keep my camera on, and I cannot present anything right now.
Okay, no worries. I've just changed it. It's a small software that we have developed for Teams, which is doing that. Okay, no worries. Okay, coming back. So this is private endpoint and public endpoint. Is the concept clear? Good questions, by the way. Good questions. Bhaskar, if you can just research about John's question in the background, I'd be super thankful. Okay, any other questions? Good questions. Love it. Are we okay to move on to load balancers? Is this making sense? Yes? No? Somewhat?
Yeah. Hello.
Yes.
So in a hybrid environment, so if I have both on-prem and the cloud, so if I need to communicate between the PaaS and the private endpoints of the subnet, so what would be the preference? So do I need to, as said, like initially you said, like service endpoints can't be communicated for the on-prem. So is it for only I need to choose via the private and private link only to communicate? So
Yes.
do you have any preferences for that?
Yeah, that's pretty much it. You summed it exactly right. It's last I checked, service endpoint, it wasn't possible. They are creating a preview where you can integrate it with on-prem also, but I don't think it's still available. But private endpoints you can. Okay. All right. I hope that answers the question. Good question again. Now, next we have load balancers. Now, before I start load balancers, I need your help to get started with load balancers. So, So, can anyone quickly tell me the OSI model? Can anyone quickly tell me the 7 layers of OSI model? Seven layers, anyone?
Physical, data, network, transport, session, presentation, application.
That's awesome that you remember it. Even I don't remember it sometimes, being a network engineer. That's embarrassing. But someone came to me last class and said they have a very funny way of remembering it. Something which goes around Australia Post Service say they deliver, but they never do. Something around that, which was pretty funny. Application presentation.
I usually go bottom up.
Okay. It's ask ChatGPT. Yeah, definitely. All the questions you ask me, where do you think the answers are coming from? Everything comes from ChatGPT. Okay. So basically, these are the 7 layers. Bing Chat. I love Bing Chat. It's a little slow, but it's getting better and better. Okay, so these are the 7 layers, but what we're going to be interested is in the layer 4 and layer 7. So we are interested in these 2 layers. Now, let's talk about load balancers. Now, whenever we talk about load balancers, we talk about what type of traffic are we load balancing. So if we talk about layer 4 load balancers, so we are doing transport level load balancing. That means load balancing on the basis of ports and IP addresses. So we are doing load balancing on the basis of ports and IP addresses. So why do we need load balancing? Now, for example, this is me and I want to access a website that you have hosted on this virtual machine in Azure. What do you think is the problem with that? What do you think is the problem with I have hosted this website capacity and availability? Sean, thank you so much. Basically, what Sean means is, what if this virtual machine goes down? What if this virtual machine goes down? So you need multiple virtual machines in the backend, which is hosting this particular website. Now, that is okay, but this virtual machines, how do this virtual machine had one public IP address, this virtual machine had another public IP address. This is not working with me, because if that is the scenario, if I have public IPs for each of the virtual machines, then every time this virtual machine goes down, I have to redirect my users' traffic to this VM. That's not working for me. So what I do is I create a public load balancer. And I'm talking about layer 4 at the minute, which is basically IP addresses and ports. So all the traffic, instead of going to the backend directly, it comes to this load balancer, which can be a public or a private load balancer. So it's a public load balancer, for example, because it's hosting my website. It comes to this load balancer, and this load balancer balances the traffic based on some rules. It balances this traffic on to my virtual machines in the backend. Now, there are multiple benefits of doing that. As Sean mentioned, capacity and availability. I'm not overwhelming any of the virtual machines. I can have multiple virtual machines, and you can set up rules, first in, first out, whatever selection criteria. So based on the IP address, as the request comes, it will send it to the load balancer at the backend. Now, from a security perspective, why this is important, whenever you select load balancers, you have two SKUs, basic and standard. They have many differences, like basic can have only 300 virtual machine instances in the backend, but standard can have 300 instances, 1,000 instances. So along with that, basic is by default unsecure. Basic is by default unsecure. But standard is secure by NSG. So whenever you create a standard load balancer, you will have to create and associate an NSG to it. You can create it on the fly as well while creating your load balancer. So whenever the traffic comes, it's secure because of that network security group in the backend. Now in the backend, you also have something called as health probes. These health probes keep checking if the backend is healthy or not. So every time this health probe will keep checking if the backend is healthy or not. Now these can be virtual machines. These can be application servers. It can be anything. So you can select VM NICs as backend, or you can select IP addresses and then you can link it to your application servers as well. So it doesn't necessarily need to be just virtual machines. It can be anything. Along with that, you can create something called as a sticky session. That means every time an IP comes, if the traffic comes from one specific IP, it will go to one particular VM. If you want, you can create those scenarios as well. I don't know why you would create them, but if you want to, you can create those scenarios as well. Now, when I talk about layer 4 load balancers, they can be regional, can be global as well. So you can create regional load balancers, you can create global load balancers as well. It can be public load balancer, which is used for your public, or you can have a private load balancer within your VNet as well. So it's up to you how you want to create your load balancers. Any questions? You might have heard about load balancers in your AZ-104, but is everything making sense? All good? All good? All good. You can see a big question, but I'll let Pascal address it. Okay. Now, These are layer 4 load balancers. When I say layer 4 load balancers, that means they are only using either source IP, and it's called the 5-tuple thing. So source IP, destination IP, protocol, source port, destination port. Similar to the concept, you can have application or layer 7 load balancer, also known as application gateway. So concept remains the same. Traffic that comes goes to this application gateway, goes to this app gateway, based on the rules. So it first listens to the traffic. Now this application gateway can basically do TLS inspection as well. So it basically splits open that packet, looks at it, re-encrypts. It can do that as well. So it has some listeners which will keep listening to the traffic. And then again, based on the rules, it will load balance to the backend. It can be virtual machine, containers, whatever you want to load balance it on, app services, whatever you want. So you can do multiple kinds of load balancing in the backend. Again, you have health probes. Why do we need health probes? Anyone? Why do we need health probes? Just to see if to check the health of the instance. So what it does is basically keeps pinging this instance. It keeps pinging this instance saying, hey, is this virtual machine alive, virtual machine alive? You can do TCP pings, UDP pings. So concept remains the same, but the traffic here is going to be layer 7, HTTP or HTTPS based traffic or URL based traffic. Application gateway is going to be regional. That means it can only work within a region. So they are regional, they are not global. Also, the app gateway that you configure, they should be in the same region as your backend. So backend and load balancer should be in the same region. Backend and load balancer, app gateway should be in same region. Concept remains the same. Concept remains the same. And the last one we have is Azure Front. Oh, by the way, you can implement WAF with your application gateway as well. WAF is Web Application Firewall, which is basically used to stop any sort of XSS attacks or SQL injection attacks. So WAF is very important when it comes to layer 7 attacks. WAF is, thank you so much, Bhaskar. WAF is available for AG, FD, and Azure CDN as well. And the last one is Azure Front Door. Now, Azure Front Door is global. Again, it is layer 7 based. So what kind of traffic is it load balancing? HTTP and HTTPS. And how it works is pretty interesting. So you have this amazing Azure Microsoft backbone. This is our Azure backbone, which is a big network, and it's huge network, huge network. If you look at it, Bhaskar, if it's okay with you, share the link for the Microsoft infrastructure with them. It's a big Azure backbone, as if not as big as internet. It has 60-70 data centers across the world, undersea cables, big Azure backbone, which is connected to different regions. I can see someone's hand is up. Just give me a second. So it is connected to different regions. So it can be East US, West US, different regions. Now, it does have something called as our edge location. It is connected to the regions and it is connected to the edge locations. So that's done. You are facing the edge locations. So it has number of edge locations which can be accessed, and I'll talk about edge locations in a bit more depth in the next slide. So that's tons of edge locations. Now, whenever you want to access anything on the internet, for example, your company xyz.com is multi-regional. It has offices in East US or a website in East US, West US. It has websites everywhere. It's a multi-regional company. It's a global company. And if anyone wants to access this, if anyone wants to upload photos on this, so they basically log in into the edge location that is closest to them. Based on this Anycast IP address, they basically access the edge location that is closest to them using layer 7 HTTPS based routing. They will access the edge location that is closest to them. In the region, you will have your app gateway and your network services. So they'll get attached or logged into your region, download the content, and the content will be basically in this edge location in the CDN and will come to the user then. So this is how layer 7 application load balancer works at a global level. So as your front door is at a global level, it can be integrated with WAF, CDN, anything that you want. It is completely secure. It acts as a one-stop entry for your application, which are spread across different regions across the world. Okay. Your questions now. I can see someone raised a hand. Please go ahead. Who's that? Ari, go for it.
Hi, sorry, it might be a bit of off topic. Just on the WAF, it's just a current project and it's a point of interest. So when you say app gateway and not the load balancer, is it only the app gateway that has the functionality and not the load balancer?
So app gateway is looking at layer 7 traffic. So URL based.
Okay, now okay, I understood. Okay, all right. So
So-
it's not a layer 7 load balancer is what we are talking here.
Yeah, it's an application is layer 7 load balancer. Where when you talk about layer 4 load balancer, that is only load balancing based on IP addresses and ports. It doesn't understand URL.
Oh, okay, yeah, okay, got it. Sorry, I missed that point. And does it have the option to offload like SSL traffic and offload and scan?
Yes,
type of
yes. It has SSL offloading, TLS inspection. Exactly right. It does
Nice.
have.
thing? Thank you. Yeah.
Okay, Yari was asking a very good question. Again, application gateway is regional. That means you can have only regional level, whereas Azure front door is global level, layer 7 redundancy. Global. Hope that helps. Any other questions? While I've missed. Okay. Why would someone use LB instead of app gateway? LB is if I want to load balance network level traffic, I don't. For example, I am I want to access a server in the backend just for some particular purpose, just to cater to my storage. For example, it has nothing to do with URL. I basically am logging into the backend, which is nothing to do with layer 7 traffic. So in that scenario, I will use layer 4. But if I have URL, for example, I have something like Instagram. Where I have URL based traffic. So I'm uploading pictures or I'm uploading videos. So because it listens to the URL, it looks at that URL and the URL will have something like www whatever https/images in the end, for example. So I can say as soon as you see images, it goes into the images virtual machine. Or if it has /videos, it can go to the videos backend. So I can do stuff based on this URL. Hope that makes it clear. Okay. All good. If you want, you can take a quick photo of this, if that helps you later, because it's a good summary of how things are. If you want, you can take a photo of this. I'm just going to do a quick revision on the slides as well. Prayesh is asking, what about, can you repeat 300 and 100? So when we talk about normal layer 4 load balancers, you have two SKUs or two offerings. Either you can choose a basic one where you can only have 300 virtual machines in the backend and it's unsecure, it's open by default. Whereas you can choose a standard load balancer, which is more money, and it has you can have up to 1,000 virtual machines in the backend. Not just virtual machines, you can have anything in the backend. Okay. All right. Okay, I'm coming to the slides again just to do a quick revision. Slides. So we talked about a normal load balancer, which can be an internal or external load balancer. Unfortunately, the slide doesn't mention much, so I just thought I'd mention more than that. It can be a regional or a global load balancer. Then you have application gateway, where it does SSL offloading, SSL termination, TLS inspection. So the traffic comes from application gateway, HTTPS on the basis of rules, it will send it to one of the backend pools. And then you have WAF or Web Application Firewall. Now, Web Application Firewall is used to stop Layer 7 attacks. It is updated with all the latest OWASP core rule sets and all the vulnerabilities. So you have protection against the top 10 vulnerabilities in the world. It can be supporting front door, application gateway, and CDN. And then we talked about front door, which acts like actually a front door. It is layer 7, but load balancing at a global level, not at a regional level, at a global level. So that it can do multi-site hosting, custom domain certificate management, can be integrated with WAF, can do URL redirection, does support IPv6, can do session affinity as well. Session affinity basically means if a specific user logs in to that using a specific IP address, he will be always redirected to just one particular server always. So you can do session-based affinity, cookie-based affinity, URL-based routing, whatever you feel like. Okay. Yaniv, load balancers, basically the concept of Azure Front Door is it's multi-regional, region 1, region 2, region 3. Whereas load balancers, they only work within a region. So even if I create two load balancers in separate region, I can't load balance across them. I can only load balance between these two. Hope that makes sense. Okay, John wants me to go back to the last slide. Exactly right, Jose. Exactly right. And they do use, it actually does use front door. In real life, it does use it. Okay. Netflix uses Microsoft's backbone network, by the way. So that's how it works. Azure Front Door and CDNs across the world. Now, next topic is express routes. Now, express route, as I mentioned, it will be working over Microsoft's it will be working on a privately leased line connection. So express routes would be working on a privately leased line connection. So first you need to call TPG or Telstra and call them and say, hey, I need a private lease line towards to my Azure network. Can you lay that for me? You say, yeah, okay. So they will lay this private lease line connection for you. So it can be a primary and secondary line to the Microsoft Edge, and then you can connect your Azure backbone to Microsoft Edge. So this is how it actually works. It works on a privately leased line. Now let's look at it in a bit more detail, how it works. Now, whenever you say express routes, you basically talk about Microsoft's big network. Talk about Microsoft's big network. So this has tons and tons of data centers connected across the world using undersea cables. It is connected to different regions. It can be, say, East US or Australia East, for example. New Zealand people, you will be getting your own region, I think, pretty soon. So, or East or West US or whatever. So it is connected to different regions all across the world. Now, this Azure backbone is also connected to edge locations. It is also connected to our edge locations. Now, edge locations, you can imagine this as a colo or a meet me location all across the world. So you will have sort of like a meet me or a colo where you will have a setup, something like this. Some countries they call it colo, some countries basically meet me connections, where you will have Microsoft's in a big data center, in a big private data center, you will have tons of Microsoft routers. And along with that, you will have your customer routers. When I say customer router, basically the service provider routers. In case of Australia, you can be like Telstra, Vodafone, whichever routers. So I'll just select Vodafone for now because some people are from other regions as well. So you will have your Vodafone routers in this edge location, and then Vodafone lays that leased line to your company's on-prem network. So to your on-prem environment. They lay that lease line just for you. They lay that lease line just for you. Now, this again comes in multiple SKUs or multiple offerings. So it can be a local SKU. So a local SKU will only talk to region that is local to it. Only talk to local region. When I say local region, that means if this is East US and your meet me location is in East US, it will only talk to East US region only. Or it can be a standard SKU. So when you say standard SKU, it can talk to regions within geopolitical boundary. So you can have standard, you can have local, and then you can have the premium SKU, which can talk with everybody. So if you have the premium SKU from your on-prem, you can, even if you are in US, you can start talking to Australia East region pretty well. So it really depends what type of SKU you choose. Okay, so it really depends on you. So it can be like directly to your on-prem, or it can also be a scenario, something like you have a big MPLS network in your company. It's a big MPLS. And then this is connected to different companies, different regions within, or different offices within your network. All up to you, however you want to do it. So it's really all up to you how you want to do it. So these are the different SKUs. I just want you to take a quick photo of how express routes work. So basically, Azure Backbone connected to different regions across the world. If you select local SKU, you will only have access to your local region. Standard SKU within that geopolitical boundary, or premium SKU talk to anyone and everyone. Express routes are generally dedicated to a single company. They are not shared by companies. Okay. Then you also have a feature called as Express Route Direct. Express Route Direct, which basically bypasses your service provider's network and directly connects to Microsoft directly. So it bypasses all your ISP's MPLS network and directly connects to your network. So it really depends on you how you want to choose it, how you want to go for it. It's up to you. I want you to take a quick screenshot before we move on to the next slide. Any questions? Prashant is asking. Prashant, I don't understand that question. Sorry.
So, so you're referring to the private endpoint, service endpoint concept within from VNet. Let's say from on-prem, you need to access the global service. How do you? Is there a separate two different interface available in the express route?
Okay, good question. I think when we talk about service endpoint specifically, it's from within Azure Network to Azure Network.
I'm just ignore the service endpoint question. If I need to connect
any hybrid scenario is what you mean.
So okay. From on-prem to your global service, do I still connect through the VNet, or can I bypass the VNet and connect directly from the express route?
Good question. Good. I was going to come to that. There is something called as Express Route Fast, if I'm not wrong, where you can bypass everything and directly connect as well. But it's just a bit more expensive. I'll share that link with you. It's a bit out of scope of this, but you can do that as well.
Yeah.
Yeah, it's super expensive, but it is possible. I'll just open that link up for everyone. Sorry. Yeah, I think it's called shortcut. Just let me get that link up. I think I have that up and ready for everyone. Express routes. So fast path, I think it's the fast path one where you actually bypass everything and you directly connect to virtual machines within the virtual network. So it's called Express Route Fast Path. So I'll just share this link with you. Okay. You can have fast path, you can have direct. Direct is pretty same. Just you bypass the ISP's network altogether. So you bypass ISP's network completely. You also have an amazing express route which is called as global reach. So in case I have an office in San Francisco and I have an office in London and I want to connect them over express route, I can do that as well. So I can use express routes to directly connect to my office in London and Silicon Valley over express route rather than the internet as well. So you can do that as well.
So the express route is not a region scope one?
No, it really depends on how much you're paying.
Okay.
Yeah. So when we talk about encryptions, you can encrypt it using MACsec. So you will have to do it with your service provider. So you would need his help. So you can encrypt all the physical level traffic also using MACsec. I won't go into details of it. Pretty possible. I can see a hand raised. Richard, you want to come off mute? Sorry to keep you waiting.
Yes, can you hear me?
Yeah.
Just a quick question. My understanding, the express route is actually the traffic will not go in through the public internet and will go through the Azure backbone. Is that right?
Yes. So
okay. Cool.
Exactly.
So my question is, so we previously we came across the secure design question. So if the project can't afford to have express route, and if the traffic has to go through the public internet, and we have to come up with some like a security mitigation method. So that means like some like traffic goes to the public internet, but maybe goes to the service endpoint, but still go back to the on-prem gateway.
Yeah.
That considered still scaling up?
what was the last statement that you just said?
Like say the traffic, public internet traffic, like the traffic still goes through the on-prem gateway.
Yeah, so the only way you can, if you don't want to use express routes and you don't have the finances, if you think this is an expensive solution, then VPN can be the only way to do it. So you VPN and route all your traffic coming into your on-prem network if you don't want to use express routes.
So on-prem gateway can secure
Yes.
traffic.
Yes.
You have to use in VPN.
Yes, you will.
Those endpoints or something like that.
No, you can use VPN and sort of UDR. So you custom route and send all the traffic to your on-prem. That's an easier way of doing things.
Okay.
But you can set a private endpoint as well.
Yeah, well, I guess my question is, if we can't afford to have express route, what's the other alternative best solution for this
VPNs.
VPN?
Yes.
Okay.
Yeah.
Cool. Thank you.
Okay. All right. So coming back to the slides, you can have not just primary, but primary and secondary. You basically go do it using a colo, so you can directly connect to colo. Colo is a place where you have Microsoft routers and custom your service providers routers like Telstra or Vodafone routers. And if you want to bypass Vodafone's network completely and log in, the cables will be laid down by Vodafone or Telstra. But if you want to bypass their network completely, then you can use Express Route Direct, where they help you to directly log in to your Microsoft routers. Okay, now coming to speeds. I think someone. Okay. John, the link I gave you has much more details. So, and if you look at the AZ-500 learn path, it's got more details than that. No worries, it's fine. Now, talking about speeds, it really depends on how much money you want to pay. So if you want Express Route Direct, you can reach a speed of 200 Gbps, but it again depends on what SKU you select. If you have, if you don't want to invest that much and your speed requirement is less, you can go from 50 Mbps to 10 Gbps. But the difference here, when we talk about Express Route, is it's all a dedicated bandwidth to you. It's going to be a little different from the internet bandwidth, because internet bandwidth says it can be anything from 0 to 100 Mbps. It can be 0 also, 100 also. But when we talk about express routes, 5 Gbps means 5 Gbps. That's it. If you're getting lower than that, call the service provider and say, hey, I'm paying so much, but you're not giving me the dedicated bandwidth. So according to the circuit you choose or the money you pay, you can have up to 100 Gbps. All up to you, however you want to do it. All right, with that we finish networking part. Now, I'm going to open up the forum for you. I know we're a bit behind schedule, and Bhaskar in the background is saying, hey, Amir, what you doing? You're killing me. But I'll cover up time tomorrow, I promise. But before starting host security, how are you feeling? How are you doing? Are you comfortable with what we studied? How are you feeling? Just pop it in the chat. Hey, I'm super comfortable. Hey, I'm comfortable. Hey, things are making sense. Hey, Amir, you speak so fast. What are you saying? What do you think? Okay. Jose says he felt like he learned a lot. What about others? Are you okay with my pace and my style? Do you want me to change anything? Okay. Ha seems excited. Just one word in the chat, or one emoji, or one GIF, whatever you feel like. I'll give you a minute before we start. How are you doing? How are you feeling? Arvind, yes, I do take AZ-700, which is going to be in next week, I guess. Next week I have an AZ-700 schedule.